To our very first virtual public forum. All of us at the Missisquoi River Basin Association, thank you for joining us for Rescue the River. I am Lindsey Wight. I'm the coordinator of the MRBA. I'm joined by a couple other presenters who I'll let introduce themselves.
I'm Ellen Fox. I'm a project manager.
I'm Ari Lattanzi, the Education and Outreach Coordinator.
So I just recently realized that this year is 25 years of the MRBA being an official organization of our river. So yeah, it's pretty exciting. For the last 25 years, we have been holding true to the mission to restore and maintain the integrity of the Missisquoi River Basin. And we really try to work with our communities so that the uses and the values that they want to see are upheld by the river and the quality of its water. The basin, as you can see from this lovely map that Ari made, is 855 square miles and in northern Vermont and up in Canada. All of our actions happen in the US side, although there are great partners working in Canada to make sure that the river up there stays clean and healthy as well. The majority of our watershed is forest and farmland. And some of the major threats that we'll be addressing tonight with our topics are erosion, runoff, and invasive species. I am going to throw up our first poll just to get a sense of folks' connection to the MRBA. This is a simple one. Just click yes or no if you have volunteered with the MRBA, whether it's a tree planting or collecting water samples as a board member, attending any of our events. We just want to gauge who's out there and listening tonight. 50-50. Perfect. So we'll leave this up for a few more seconds. Just kind of a fun one to, like I said, gauge who's out there and get used to using polling. So thank you guys. I'm going to end it. And I want to highlight one of the tools that we use while we are addressing these threats, and that is our tactical basin plan. A tactical basin plan is written for every watershed in the state. It's written and managed by folks at the Vermont DEC, and our basin planner, Karen, is online with us tonight. So hi, Karen, thanks for joining us. And thanks so much for all the work that you do to make sure that our basin gets all the attention that it needs. These plans are rewritten every 5 years, and ours is currently being revised and rewritten. So it's an important year for us at the Missisquoi River Basin. These basin plans help determine priority actions for our watershed and where the state funds can be spent. So it's important that we really capture the priorities of our watershed within this basin plan. And the ways that you guys can help as watershed residents or folks that care about our watershed is just to share your concerns, your hopes, and your priorities with us, and we'll make sure that those get incorporated into the plan. Now, areas of concern can be geographic. If there's a specific bank that you have been watching erode, let us know. Or it can be a use area, such as the fish population is concerning to you, or any of the other river uses. Areas that you value, we really want to know about so that we can conserve our high quality water and our high quality habitat, and also protect access. So because this is our year to be rewritten in our tactical basin plan, we're going to ask you guys to communicate with us, communicate with our partners, and make sure that we are capturing all of those priorities within this basin plan. And the ways that we'll do that include a public survey. Ari's been working with our partners to create this, and so we'll be sending that out in the coming months. Please, when you see that pop up in your email or on social media, fill that out and encourage others to do the same. We'll also be holding some public and probably virtual meetings to discuss watershed concerns. And we also are always happy to talk to you guys one-on-one. Our contact information will be on the final slide this evening. For all three of us, you can reach out via email, via phone, jump on our website. We would love to hear from you. So I'm gonna ease us into the topics this evening by talking about our water quality history. The MRBA has been monitoring water quality officially and through sampling since 2005, and you can see that we have scattered our sampling locations well throughout the US portion of our watershed. We've collected samples with the help of numerous wonderful volunteers, some of whom have called in tonight. Thank you guys, thank you, thank you. At 79 locations. And we collected those samples from 2005 to 2019. The parameters that we typically sample for are nitrogen and phosphorus. These are nutrients that flow through our water system and build up in the Missisquoi Bay and cause those toxic algae blooms that are so problematic. And the best way we can address the issues we have is to see where the inputs are coming from and then work to fix those eroding banks or those runoff issues. So as I said, we collected samples in partnership with the DEC for about 15 years, and then 2020 blew everything up. So we got to view 2020 as a year of adaptation, and we took, instead of doing the holistic sampling watershed wide, we took a more focused look and worked directly with some landowners by piloting our Water Insight program. And I'm going to turn it over to Ellen, who will tell us more about this program.
Yeah, thanks very much, Lindsay. And thanks everybody for being here. So Water Insight this year was a new program. We're still sampling for nitrogen and phosphorus, but instead of a wet chemistry sample that we would send off to a lab, since that wasn't available, we started to use litmus style test strips that provide an instant result. We use these results to compare nutrients in and around one parcel. So it might be a contiguous piece of land, and in other cases, it's several adjoining plots. But the real key for this program is that we're really working closely with landowners to understand the surface water dynamics that are happening on their property. You know, the relationships that we're building start with just sort of conversations about what we think we know, and then we can go out and design a testing system that can answer those questions. So we'll go to the next slide.
Sorry.
So today I'm going to share just a really simplified mock-up example of our method. We share the results of the projects only with the landowner, so I'm not going to display actual projects here. Sampling sites that are near where tributaries meet the main stem of the river, sort of by their nature, have very, very broad contributing areas. And so sampling at those sites provide general trend data that's helpful over long periods of time, but it doesn't really answer the kinds of questions that a landowner might have. You know, those kinds of questions are, you know, where and how are nutrients entering the water flow on my property? Are there places where I can attenuate sediment and nutrients? What land management practices are reducing or preventing or promoting nutrient runoff into the waterway? And, you know, these are the really big questions that lots of folks are pursuing. And so we're working just with individuals to look at small parcels. To assess the source area for nutrient loading, first, looking at a study site, we delineate the subbasins. So, you know, the sampling sites, we can strategically place them so that we can get to smaller areas of land, but oftentimes, you know, where we can go and sample is determined by accessibility. Is there a bridge? You know, how far in do you have to hike to get to a tributary? Those kinds of things. We'll go to the next slide. So to delineate these subbasins within our study area, essentially we use stream stats to delineate the drainage areas for subbasins within that parcel or adjoining parcels. Once those are delineated, it's loaded into an ArcGIS system so that we can do some analysis. So in this simplified example, we're looking here at the northern portion of the study area, and we have sampling sites A, B, C, and D, and then the subbasins that are draining through each of those sites. So site A drains the entire area. Site B is draining areas 2 and 3. Site C is draining just area 4, and D just area 3. So what we'll do is over the course of the season, we'll measure the nutrient load, phosphorus and nitrogen at each of those sites every 2 weeks. And for this example, I'm going to walk through the calculation for nutrient load just for phosphorus. The method would be the same for anything that you can measure the concentration, really any constituent, but just for simplicity. So one thing to note is the measurements that we're taking with this litmus strip test is not comparable to, the test that we would send off to the lab. So we're not using these to sort of enlarge our existing database, but rather, again, just to look at relative effects for a single landowner within their property. So we're measuring concentration. And so to get to the mass load, we need some way to estimate the discharge or, the volume of water that's flowing through that site. So we do this using the nearest gauging station. There's little shacks you see along the river. There's one in North Troy, one in Berkshire. In this example, the nearest station would be North Troy. So once we have the concentration and the discharge data, we can estimate that nutrient mass load. Once we have that load, what we really aim to do is attribute that load to the corresponding area that's delivering that load. And again, to find spots that are contributing areas and also, maybe more importantly, attenuation areas too. So we'll go to the next slide. So this is just a little sampling of this method. So you see on the slide, we have samples at each site, sample A, B, C, and D. Just down from that is an estimate of the discharge per square mile. So to get to that discharge per square mile, I've pulled gauge data from the North Troy gauging station. The discharge used in this example, I've only pulled one date just for simplicity again. In the actual calculation, each different sampling date would have a different discharge amount at North Troy, depending on weather conditions and a variety of things. So that would be a dynamic number. So anyway, in this example of 95 cubic feet per second, the discharge at the Troy station, during the summer months will range from a low of 24 cubic feet to 2,400 cubic feet per second. So this is a relatively low flow day. If we take this flow though and divide it by the entire area that's discharging to that site, we can get this discharge per area, per square mile. So I use that factor to then look at our subbasin. So the third step here is to calculate the discharge for just that subbasin. And you can see that in our example in the bottom table where site A in the second column, there's discharge per square mile for that outlet, for that specific outlet of the subbasin. Once we have that, we have a concentration at a site, we have discharge estimate at a site, we can multiply those and come up with a mass load number. So you can go to the next slide. So once we have a mass load estimate, the actual amount of stuff, how much phosphorus is flowing through that outlet, we can go back to our map and compare, where is that phosphorus coming from? So, area 1, the small sort of green sliver at the very end of our basin that we're looking at, would be the measurement at site A, that load, minus though the site B and site C load. The same down the line, area 2 would be the load at site B minus the load at site D, area 4, the load at site C, and area 3 at site D. So it's just a relatively straightforward way of looking at an estimate of how much stuff is moving through different smaller segments of a much larger watershed. Once we have these comparisons, you know, we sit and work with the landowner and we can then qualitatively assess, you know, what's happening in terms of land management and activity in those areas. This similar technique can be used before or after an erosion control project or another kind of change in land use, so that we can compare before and after results, again, in a relative way. Next slide. So the relationships, again, I think are really key here. You know, we're working with landowners who are really interested in responsible land stewardship, and we get to engage in a method that's based on peer learning, you know, and investigation. Landowners are using this to guide nutrient management plans. Somebody who's interested in an erosion control measure could use this, again, like I said, for a before and after picture. This can provide insight to municipal planning boards. You know, there's a lot of focus on flood resilience right now, looking at particular areas in their town, specifically on town-owned properties as well. You know, that maybe it makes sense to earmark an area that's to be restored as floodplain, as an attenuation area. So if you're interested in this work, we would love to have you join us in it. We're seeking both landowners and samplers. So as a landowner, you know, the expectations are pretty minimal. It's essentially your interest. So you'd need to invite sampling on your land. You know, somebody would come by every couple weeks and traipse about a bit and grab a sample. Meet with samplers a couple times a year. First to sort of set up the project and identify sampling sites, and then again to discuss results. Samplers, you know, if you love to be out and about and in the river, this is a great way that you can explore a new place and make a relationship with somebody who's maybe in your community or in a nearby community. And your responsibility, you know, we can train you to do the sampling, and you would just go out and collect samples every couple weeks. And then we can do the data analysis on our end. You can be involved in that as well if you're interested. So I think what we'll do is do another poll, and you can sort of express your interest in that quick poll. And while we're doing that, we'll see maybe if there are any questions.
Yeah, is a question about, do you have to own a large parcel to be a part of a survey like this? No,
not at all. You know, any parcel is fine, and it doesn't have to be adjacent to the river. You know, anywhere in our watershed is contributing. You know, there does need to be some surface water flowing across your land for it to be, you know, a fit. We need something to sample. The two pilot projects, two of them, you know, the sort of sampling extended to neighbors to have a boundary condition. So it becomes, you know, a sort of a larger effort a little bit in a community on a one-on-one basis. But so the answer is no, you don't have to be a large parcel owner.
And then we have a question about, do you need to be in the watershed? This person is hailing from outside the perimeter of the MRBA.
Right. For MRBA to do it, you do need to be in the Missisquoi watershed. But that being said, I'd be more than happy to connect you with resources to get the materials and the little Excel model that does the calculations. And you would be able, you know, we can give you some guidance on how to pursue it.
Great. Thanks, Ellen. All right. I'm going to close down the poll. So if you haven't gotten your answer in, you got 2 more seconds. Okay. Great.
Well, great. Thanks very much.
All right. So switching gears, we are going to talk about our new program, Knockout Knotweed now. So I'm assuming most of us are familiar with knotweed, Japanese knotweed specifically. It is an invasive species that is very prevalent in our watershed. So this botanical drawing just highlights some of the recognizable characteristics of Japanese knotweed. The stem is hollow and generally reddish with green ovate leaves, and there are small flowers that produce small seeds towards the end of the summer. The kind of frustrating thing about Japanese knotweed is that it is a plant with a rhizome, and it is a very resilient plant that is very capable of spreading through even small bits of its material. So it does produce seeds. Most of those seeds are not viable. Most Japanese knotweed plants are clones of a female plant. It is possible for them to produce hybrids that are viable, but mostly we see knotweed spread throughout our watershed through the transport of either pieces of the stem or leaves, and especially pieces of the rhizome. So that is something we're going to discuss as we learn how to best control this invasive species. So this is what knotweed tends to look like along our waterways. It is generally taking over and shading out any of our native plants. This is just one patch in Riverwalk Park in Montgomery. So our next slide is a map, actually. We had Arrowwood Environmental, funded by a Lake Champlain Basin program grant. They actually paddled this section of both the upper Missisquoi and the Trout Rivers and took note of the patches of knotweed that they encountered. So the green dots are the patches on the left bank going downstream. The yellow dots are the patches in the center of the channel, whether that's in an island or some sort of sandbar. And then the red dots are on the right bank. So you can see that our upper watershed in Westfield and Troy is less impacted, but there's still quite a bit of knotweed, and further down the river is heavily impacted by knotweed. And I saw a question about how knotweed spreads through the rhizome. That is part of why we see it so much along our rivers, because Japanese knotweed can get washed downstream. It has a large root system, but not very strong or stable roots. So we see that knotweed can basically erode the bank, and then even small pieces of that rhizome, if they find favorable conditions with bare soil and enough moisture, they can regenerate. So we want to make a difference and change that. So I'll turn it over to Ellen to talk about her pilot project she did this past summer.
Thanks, Ari. So again, this is Riverwalk Park in Montgomery, and knotweed really likes areas of frequent distribution or frequent disturbance and full sun. So this is right along the pathway that leads down to the water. These conditions, where there's a lot of foot traffic or and full sun can really quickly outcompete native vegetation. So this photograph was taken on June 5th. The next slide shows the installation of a control measure that we piloted just as a little experiment this past summer. So we installed this control measure on June 5th. You can see in the center of the photo, it's a metal mesh grid. So it's hardware cloth essentially with 1/2-inch openings, and it's staked to the ground at 5 to 10 centimeters above the soil surface. The stakes, we just use tent stakes that have an eye in the head of the stake so that we can attach the mesh to it. You can see that we had to remove a lot of vegetation to install the control measure. Our timing was just very late. It's far more ideal to install the mesh before the first shoots are up in the spring. By waiting, we had to very carefully dispose of that excess vegetation that we removed. As Ari said, the plant can regenerate from a segment of the rhizome or a segment of stem. So the best practice to remove and dispose of this vegetation would be to completely dry the material in a spot where it's elevated above the ground, so it has no soil to take root again. Once it's fully desiccated, then, you know, it could be burned or it could be composted at that point. But particularly with composting, again, it's really important to make sure that the plant is completely desiccated and can't propagate at that point. So the next slide is the sort of what we would call before and after maybe. So we installed it on the 5th. By June 11th, there were little shoots that were coming up again. The method of control here is to allow these small shoots to grow up into and through the openings. And as they get bigger, the diameter of the stem increases and the mesh chokes off the shoots and they wither. When this happens, this triggers the rhizome to send up another shoot. And this increases the frequency of this through the season. The goal is to have the plant, you know, do this with more frequency than it normally would, so that it begins to deplete the nutrient and energy resources of the rhizome. There does seem to be somewhat of an effect for, you know, as it sends up subsequent new shoots, that it kind of smothers the plant a bit. So there's that sort of secondary mechanism happening. But even with that, you know, this won't kill the plant in a season. Rather, the goal is to weaken the rhizome system over time. In the UK, they've used this method. They've reported up to 5 years to really eliminate the plant. So in the next slide, you can see at the end of the season, we went back and I had removed vegetation equally in two plots, done the mesh control in one plot and not in the other. And so at the end, took all the vegetation that was there, all, you know, any material above 5 centimeters, and compared, you know, the mass or the weight rather of the vegetative matter. So it does appear that this reduces the vitality of the plant, even just in one season. Where there was mesh, I had 1¼ pounds, and when there's no mesh, more than 5½ pounds of material. So it does appear, like I said, you know, at first glance, that this has an impact on control. Some things that we did learn: it's important, again, to get there before the first sprouts are up in the spring, so that you don't have to plan for any disposal. If that's not the case, though, you can plan ahead. Have a spot already prepared before you make the cutting to dispose of the cuttings, you know, to a place to dry them in an elevated place. So we did learn a lot. We're planning to do this again, to continue, and actually the mesh installations are still in Riverwalk Park. We chose to leave them there over the winter in some of our test areas to see how they fare. And so for this coming year, though, there are several other things that we're going to do. I'm going to turn it over to Ari. She'll talk more about our upcoming prevention and control measures.
Great. And thank you to everyone chiming in the chat. I saw that Jeff installed some wire mesh in the late fall, so we'll be interested to hear how that turns out. And we are hoping to continue these good outcomes with funding from the Lake Champlain Basin Program again. This is our Knockout Knotweed program that we'll be launching this year. So Knockout Knotweed is a 3-prong strategy. And the first prong is really key, is the spread prevention. So as we saw on the map, you know, knotweed is very prevalent along our banks, but there are still areas where it hasn't gotten a foothold. And we really want to prevent that spread, because it takes multiple years and a lot of effort and resource to remove knotweed. If we can get ahead of it and restore our native species, that will save us a lot of work in the long run. So starting in the spring, as soon as the snow melts, we want to get out and survey the riverbanks of our waterways and see where we encounter scoured banks with bare soil, because that could be a place where knotweed gets an easy foothold if any of that rhizome washes downstream. And we'll be on the lookout also for any new knotweed invasions to add to our map as a way to monitor. So you can see in this photo how the knotweed, you know, slumps off the bank. It doesn't have very strong root structures. So any sort of that bare soil is then contributing to erosion and increased nutrient loads, and also moving that rhizome and those plants downstream where they can start a new invasion. So we'll be looking for volunteers in April and May. I saw that there was a suggestion from Karen for getting Girls and Boy Scouts to steward sections of the river, which would be fantastic. We really appreciate that. So another quick poll just to see if any of you would be interested in becoming a monitor, and that could be anywhere throughout the watershed. So just give a quick yes or no if you would like to be part of this stage of Knockout Knotweed. And Rebecca noted that there's a record of erosion on the banks by Enosburg and Highgate. So we'll be looking into that data as well. So part of this spread prevention, once we've identified the banks, we will be picking sites to go in and plant native vegetation so that we can stabilize the banks and also prevent knotweed from getting established there. All right, and then the next prong of our approach is looking at control methods. So this will be continuing the pilot that Ellen started. So we'll be looking at a variety of mechanical control methods. Chemicals are used to control knotweed, but we wanted to pilot methods that homeowners and municipalities could use without getting that sort of licensing or that sort of expense. So we'll be looking at the hardware cloth, mulch, grazing, anything we can really get our hands on. So we are going to be installing test plots in 3 locations, and we would love to have some volunteers come to help us install those and learn with us how those methods work. And we'll be looking to host an event in early spring, right when the new knotweed shoots start to emerge. So just a quick poll to see what sort of interest people have in either attending that event or helping us survey those sites throughout the summer.
All right, 2 more seconds. Thank you, guys.
All right, and our third prong of the Knockout Knotweed is the really important and fun community engagement and education. So we want to have these test plots as a demonstration project, but we also want to assist people in tackling knotweed on their own property. So our partners, You Matter is the Upper Missisquoi and Trout River Wildland Scenic Committee. They are providing a landowner grant program, which will offer funding and support for landowners to control knotweed on their private property. So we'll be offering mentorship and resources to people who are interested in that program. And then in the fall, we want to have a community event to assess our methods, see what the data shows. And it can be really frustrating to do battle with knotweed year after year. So we want to take the time to celebrate our progress and have some fun. So we've got some ideas for crafts with the carefully dried knotweed. Knotweed is edible, so we will be providing some knotweed snacks to taste test. And we will host a bonfire so we can safely dispose of the dried knotweed. So if you'd like to be part of that grant program and get funding to tackle knotweed on your own property, please give us a quick response to this poll.
Ari, what are some of the ways that knotweed's edible that you've explored or are?
So it is primarily the young shoots, and you want to get to those, before they get too hard and woody. And also be careful where you're harvesting to make sure that they haven't been sprayed by any sort of chemical. But I've heard that they are a little bit like asparagus or a little bit like rhubarb. So I'll be making knotweed ice cream. A friend of mine has told me that it is surprisingly good. So we will get a chance to taste test that. And there are a variety of recipes online. So we'll see what we can whip up for you.
Great. Right, I'm gonna take back over to highlight, thank you, Ari and Ellen. They both highlighted some great volunteer opportunities, but I wanna highlight some of the other sort of more institutional ways. Well, one's institutional, one's a new way that MRBA has recruited volunteers. We do have opportunities for volunteers to assist us on a one-time basis or on an ongoing basis. One of those is our tree planting activity. We have been planting trees since we became an organization. We hate to let a spring go by without getting out there and putting trees along our streams and our rivers. And last year we did manage to get tree planting done, but we desperately missed our volunteers. Our MRBA board and staff came out and planted, and we hired a fantastic contractor to help fill that need, but we do love getting our volunteers out as well. What these look like is volunteers meet MRBA staff at a predetermined location and time. We bring all the tools and the trees, and volunteers show up ready for field work with appropriate attire, water, snacks you might want. And this year we will be ensuring that we follow all of our state COVID guidelines, of course, while we're doing that. But we will be having tree planting opportunities when the ground thaws, so late April, early May. Another volunteer opportunity that we piloted last year is our Adopt a Site program. This is an ongoing volunteer opportunity, but it is self-directed. So we piloted this project because we wanted to link watershed volunteers with special parts of the river in a very real and meaningful way. And so we match volunteers or families up with one specific location. It can either be of our choosing. If you're looking for a new favorite spot on the river, we're happy to recommend one. Or it can be a spot of your choosing if you've already got a place that you know and love. And we will provide you training and documents and a nice little tote bag full of goodies. And as an adopter, you commit to visiting that site. We ask twice a month and collect information, pick up any litter you might encounter, and then share out those observations that you have made about your site. So that's an opportunity that we will be happy to accept volunteers for this summer. And then I just want to sort of summarize all of those volunteer opportunities. We do have those one-time opportunities, such as the tree plantings, the stream walks that Ari talked about, looking for erosion and trying to get out in front of any Japanese knotweed infestations. We will be seeking volunteers to assist us with the installation of some of those control methods at our trial sites. And then in the fall, we'll have that nice celebration and check out how those trials went. Our ongoing volunteer opportunities include the Water Insight program, as well as collecting water samples that we hope to be able to send to the lab throughout the watershed. We're going to hopefully be able to run both of our water sampling programs this year, both the watershed-wide holistic look and the Water Insight program. We'll be looking for water samplers who will be committed to sampling their sites bi-monthly throughout the summer season. And we are also looking for landowners who are interested in having an intensive look at the water moving across their landscape. That Adopt a Site program that I just mentioned. And then we also will be looking for folks who are interested in checking out our knotweed control experiments and committing to going and taking pictures and monitoring the site and letting us know if there has been any issues, any flood damage, any people moving the mesh or anything like that. After this webinar, you will receive an email that asks your interest in any of these programs. So we just request that you respond to that survey if you have interest, and we will be happy to get in touch and talk more about what we can do. And I had promised our contact information, so reach out. You can reach all three of us via email. You can reach us via phone. You can always visit our website and connect with us that way or on social media. And we would love to take some more questions if folks have some. I think there's been some chatter in the chat as well. But if you've got a question, type it in the question and answer box or write into the chat. Or you can also use the raise hand function and I can enable you to talk and ask your question verbally.
I'm going to hop in quickly because Sally had a question about knotweed, asking about burning it after it's completely dried. So the Southeast Vermont SISMA conducted an experiment where they dried out different parts of the knotweed plant and then left them in ideal conditions to see if they would regenerate. And their findings were that anything above the soil, once it had been completely dried, even when it was given ideal conditions, did not regenerate. But the rhizome can be completely dried out, but then regenerate still if it's given ideal conditions. So once it's been completely dried, it should be safe to burn and to compost even, as long as the cells of the plant above the surface have been killed by that dehydration process. But with the rhizome, we don't plan to disturb it because it can come back. Our strategy is really to tackle the biomass above the ground, deplete the energy from the rhizome, and then let it die in place under the soil.
Thanks, Ari. Ellen, can you talk a little bit more about, you mentioned that they've used this method in the UK, but it takes many years to actually kill back the plant. Can you talk a little bit more about the timeline?
Right. So they found that the first year and the second year are about equivalent in terms of the amount of biomass that's reduced and above ground, that by the third year that they're starting to see that the plant is really hindered, but that it takes a couple of subsequent years for native vegetation to move into that area. I think you can kind of go and see it in our watershed too. If you look along heavily traveled trails where there's some knotweed interspersed, but it's maybe under a woody canopy, the native vegetation still sort of has a fighting chance there. So when it's in partial shade, our native plants can still compete with it. That's kind of what happens at like the third and fourth year, that the native vegetation becomes, starts to come back a little bit. Again, like Ari said, they've not like disturbed it. In some areas they did endeavor to dig up all the rhizome, and that sort of exacerbated the problem, that it would create a new sort of knotweed bloom, if you will.
Great, thanks. What do you expect to be different if you get the control methods out earlier?
I think that if we get the control method out earlier, well, we won't have the sort of disposal problem with all that vegetation. But it'll just provide a much larger, a longer test period, to really see, like my going in and cutting a control site, I don't know what kind of impact that had on the natural sort of course of the, season for the plant. So it's just less interference from me, basically, to see what really is happening with the life cycle of the plant seasonally. I'm really curious to see with Jeff's experiment too, of putting the mesh in place. It's always a question, do you leave it in place? What happens during spring flood? So that's one of the things that we're going to be looking at Riverwalk as we have snowmelt, to be checking that regularly to see that it's staying intact. Is it catching other debris that will sort of defeat the experiment, or maybe that additional debris is even advantageous to further smother the plant. So yeah, it'll be interesting to see what happens.
Great. Well, thank you guys. Not seeing any other questions, but I do want to say thanks to everyone for attending. Please watch.
Thanks everyone.
Survey follow-up, and I will be sending out a link to the recording if you want to share it around or watch any particular part again, and I will include our contact information with that, so you can write out to us directly about any of the things we've covered tonight. So again, thank you guys. Please have a wonderful evening, and everyone stay safe.